Hello everyone, welcome back to MOLEK-SYNTEZ. Who is ready to synthesize some moleques? In case you haven't figured out, we're synthesizing molecules, right? I don't know about Romanian, but that seems pretty clear. We're going to move on to DMAA, I think that says, which is methyl, that's an H, right? Methylhexanamine? Okay. So what do we have that looks like this? We're getting a single N attached to a bunch of C's. This is a weird shape, isn't it? Ammonia might just be the simplest way to get, because like the only other way to get nitrogen is with carbamide, which does not look very amenable to this, right? So instead we start with ammonia, which means how do we piece together all these hydrogen, or these carbons? We need 7 of them. Which is actually not like the easiest thing in the world, right? We have ways to get 3. You know, propene has been a bit of a workhorse for us. We can get 3 from it. And we can get 2 and we can get 1. But in order to get 2, we have to like buy a bunch of oxygen we don't want and then throw it away, right? Kind of stinks. It's hard to do. Just more busy work. So it kind of seems like this is 2 propenes and a methanol where we throw away the oxygen. In principle, like, you could imagine doing it with just propene, but it's like a lot of work. Because you would kind of like, you'd have to do it in a cycle of 3, right? You create 3 propenes and have 2 carbon left over. And then you have to do something in the next cycle that's different from what you did in the first cycle. In that cycle, you create 2 propenes, combine them with the 2 you have left over, and now you have 8, which is 1 left over. Finally, in the last cycle, you create 2 propenes, use your 1 left over, and you've had the perfect 7. And like you've created a cycle that creates 3 instead of a cycle that creates 1. Possible, right? But seems dreadfully hard compared to just using 2 propene and 1 methanol each time. And the methanol is, I think, not that hard to get connected up, right? You just blow up the oxygen, and then this is well suited to be slotted in like here, maybe, right? Because this is basically what propene already looks like. I don't know. I'm not sure exactly how to do it, but well, I guess that is a question. Where exactly? Because which one of these 7 carbons is the one that is going to be attached from the methanol? One of the ones in the middle doesn't make much sense, right? You kind of want 2 contiguous 3s and a 1. And so the 1 has to be on one of the ends. It can't be interrupting anything. So if you go here or here or here. I don't really know which of those is easiest, honestly. Can we just actually, like, put these down all right next to each other and not have to move anything? Just shuffle hydrogens around? That would be pretty nice, wouldn't it? Let's see if we can do something that looks like that. So, like so. Give me my ammonia, please, here. And the methanol, I don't know, here. Right, and then just like move hydrogens around until everybody's happy. Where exactly the hydrogens have to go is less clear to me, but you can sort of see there's a number that they have now and a number that they want to have, and those are different. So that's a reasonable direction to start tackling the problem anyway. One interesting thing to note is this carbon has one too many and this carbon has one too few. But you can't so easily shunt them because the nitrogen's in the way. You can't get a direct angle in there. Yeah, what do you do about that? Okay, so suppose that then I had the... Well, actually, no matter what you do, that's going to be an issue, right? I was thinking, what if we moved around the methanol, put it down here or something? But that's not going to change the fact that if we have the nitrogen starting here, you can't reach this guy. So what if we made the nitrogen start here and push it into place later once we've adjusted this problem? Right? 4 starts by shunting a hydrogen, and now these guys are looking closer to happiness. Yeah, in fact, all we have to do to get everything, to get these all to bond together properly is remove the oxygen and remove one of these hydrogens, and we'll be all set. That seems pretty cool. So maybe while that's happening, another emitter sitting here, who's at 5, can just immediately push this into place. Yeah, that worked. And then 4 can immediately remove the hydrogen. Now it's ready to bond with this. In order to make that happen, we have to remove a hydrogen from here, right? I'm kind of thinking I have enough space to work with that I can just like use another emitter for that sole purpose. Why did that not... Oh, I need to add one. I need to add one. I need to add one. So is there some kind of shunting business I can do here? I don't... Maybe. Maybe. If I can have you instead... this is looking a little bit dicey, isn't it? Oh! Look at that wizardry, right? Shunt it as it's being moved so it doesn't have time to connect with this guy. Well, I guess actually they wouldn't want to connect, I think. Yeah. And then it comes up here, ready to join up. Very nice. Oh, but the problem is now there's no... We wanted that time gap, right? So that 4 would have a chance to do the shunting on these 2 carbons. Now there's no time window open for 4. Or no, that's not true. 4 did that already. Didn't he? Yeah. So that hydrogen minus that he has planned is actually something from an old version of the plan and not what I want to do anymore. Okay, great. So this is all very lovely over here. I'm highly in love with that. And to revisit, we just have to adjust these 2 carbon atoms. Well, and I guess not this carbon atom. this oxygen needs to go, and this carbon needs to be desaturated. I don't know what the right word is. So we can do that. Now, can I do it? I don't want to do it on the first cycle, because then it... Oops. Then I can't predict whether this carbon will bond with... will form a double bond here or a single bond here. So I really would like to wait until cycle 2 for this action. Now it's bonded up the way I want, right? And it's kind of fine to wait till cycle 2 because this guy's going to be busy for a little while anyway. He has to add a hydrogen and then delete the oxygen to make this work. Oh look, this bond already happened. How nice. Okay, I think we made the right molecule, right? We can't, like, do a submit here, right? I've checked this like a million times and it never works. Yeah. They're not done bonding. Whatever, we'll put it here. I don't totally understand the rules for what you can do in the same cycle and what you can't, but... Okay, this one should do quite well on cycles. It's hard to imagine doing better, right? Okay. But I'm not, like, a prodigy, right? Lots of people found this solution, or something like it. Did quite well on symbols, though. Interesting. So I wonder... Give me the settings, please. Show me, like, the top 10th or something. Because it's sometimes hard to tell exactly how well you're doing on these. Yeah, so actually we're doing better than the 10th percentile on symbols. And, I guess that's not a surprise. And competitive on modules, but not really there on cycles. Interesting. So you can do it. I mean, I guess basically we took 3 cycles, and this is telling me there is a 2-cycle solution. I guess that's not much of a surprise, because I'm pushing this nitrogen into place to... If I wanted to adjust this solution to use fewer cycles, I could do so relatively easily, because all this 4 is doing is I'm having it do 2 operations in a single cycle. Operations on 2 different atoms, even, in the same cycle, which is pretty cool. That's a lot for one actuator to do. But I happen to have a spare actuator, so let's go ahead and copy this to show the other solution, which would be well, actually it's not quite so clear. My thinking was that I could just move. Have this be placed here to begin with, so there is no need for a push. Ah, that's actually, I think, fine. Like, okay, it means we can't do this shunt anymore. So, okay, my first thought was, we'll just have this start here. Now I don't need 4 anymore. I can have, like, 4 and the unused 3 do 2 operations at the same time on these guys. Very nice, right? Oh, this guy doesn't need anything done to him? I'm a bit lost already. Yeah, he does, right. And so I thought, okay, we'll do that. Something like this. And then I was like, wait a minute, but we actually did need to do stuff over here. The fact that this nitrogen was here meant we could do in a single operation a shunt, right? Do 2 operations on this at once. But now that we don't need the guy doing the move, we have another one freed up. And we could actually do 2 actuators for these 2 actions as well, right? So 4 then removes a hydrogen, while 5 adds one instead of doing that in one step with the shunt. 3 is just removing one, and 6 is just adding one where it used to be a shunt. And then this stuff can move up here, and we're done in 2 cycles, right? No. I messed something up. Why? It's not bonding down here correctly. Why not? Why don't you want to be friends? Oh, because 6 should be adding, not removing. I pressed shunt, apparently, where I meant plus. I'm not sure how that happened. Now it all bonds properly, and we can ship it. That's pretty nice, right? Yeah. There's the 240 solution, so... Still one more module than necessary, which is interesting. I bet... I mean, obviously, you can also do it with fewer symbols, which is like, that's a big surprise to me. But I bet you can do it with fewer modules if you really want to by sacrificing greatly on time and symbols. If instead of starting with 2 propenes, you start with 1 benzene and you just tear it to pieces and then put it back together again. And of course you still need the ammonia and the methanol? Methanol. So it makes some sense to me that, like, you can get at least 1 module fewer than this by just using a different molecule setup. You can probably do even better still by doing that and also using like fewer actuators. Just having each of them perform more tasks and sacrificing still more on the other axes. But I'm not inclined to do that, so we'll just be happy with our 2 solutions here. And go have a look at mescaline. It's mescaline, right? Not mescaline? It's a hallucinogen. Yes, that is a well-known fact. So what do we have here? Interesting. It looks like a benzene with 3 methanols attached down here. And where exactly does this CCN come from? It's a weird one, right? That looks like the hard part up there. Because... I mean, I guess you need to, like... take some propene to get 2 carbons. Remove one of them, basically. And then also use some ammonia. It seems very promising, by the way, the nice symmetric structure, rotational symmetry here, suggesting that you could use 1 methanol factory where you just like remove a hydrogen from it and then swing the benzene into place and then rotate it again and bring another carbon molecule into line with it. Although, where are you supposed to hold this benzene so that rotating it gets you into line with like this? I wish that I could just like, well, I don't know, I guess I kind of can, can't I? I was like, I wish there was some playground where I could just put some of these things down and rotate them by hand. But like, yeah, there is. It's the playing field. You can rotate things as you're putting them down. So I was thinking like, okay, say we have this, right? And we somehow arrange to swing it into place here and have these two bond. Is there now some easy place we could grab it and swing it? Like, I don't really want to... I want to rotate it around this point, and that's just not possible because there's no way to see that point. You have to rotate it around one of these points, which means you end up, like, moving its center of mass, which is not what I want. So you have to, like, rotate it and then shift it with, like, I don't know. If one does a left rotation and then two does a push. See what I mean? Like, we're bringing a number of things into contact with the methanol factory. And so if we also had, let's say, 6 here, removing this, and at the same time that 2 pushes, 1 removes, I think, we get something interesting happening. Not interesting enough. What happened there? The problem is that 6 is trying to remove at the same time as 1 is rotating, and we need a break in there. We need, something like that. Okay. So you can see in this way, we can like kind of repeat this pattern as many times as we want and get some methanol like jammed in there, right? Get some carbons and oxygens attached. Now they're oriented wrong, but I think that that's just a simple matter of this. Oh, I made it worse. Okay, maybe they were supposed to be like that. Okay, 6. You can shoot from this side. I'll allow it. Or how about here? Is this right? I don't understand what's happening here. Why does every side I tried to add it from come out wrong? I guess maybe I need to be adding it here. That's the problem. I'm adding it at a place where it's touching 2 carbons, and that's obviously incorrect. I need it to be down here. And now, we don't care about this one business, right? These actually can happen at the same time. Yeah, there we go. See, it looks beautiful. It's not oriented the same as this, but if we... How much would I have to rotate it to make it be correct? I think twice. Okay. Yeah. We have this, right? This guy comes here, this guy comes here, this guy comes here. It's all very lovely. And we're sort of all set on this stuff. All we have to do is, while all of this is happening, assemble the C8. What order do you say things in? I guess I don't know. I'm trying to say like what would be the chemical formula for this thing that we need to assemble in order to attach it to the benzene, or the mescaline to be. Is this like C2H6N2, or like, I don't know what order these things are supposed to go in. H6C2N2 or H6C2N, H6NC2? I don't know, guys. Whatever it is, we need to make one of them and have it ready here, right? Or here, I guess, by the time this whole process is done. So anyway, we're gonna want no, excuse me, copy. Can I copy that? I don't see a way to copy. And the game lacks a manual, so I guess I'll just do it by hand. Okay, so great. I did that because while this works in isolation, this is something we want to do 3 times each cycle, and something else, the other 3 actuators need to be doing something else during this time. So we actually do need to repeat this 3 times, at least the way I've built things. So we need then the propene that we're starting with. Let's double check that this is all like it's going to arrive in the right orientation as well. Yeah. So this molecule here is the one that needs to have a hydrogen removed from it. And I don't know exactly where it started from. It's sort of hard to trace time backwards, I guess I can do it in relation to where it was in relation to the first oxygen, right? It's like 2 carbons counterclockwise from the first oxygen. And the first oxygen is here, which is this one. So counterclockwise is here. Which I guess means we'd want, like, okay, as a like a first draft, we might want something like this. Nope, I got it wrong. Which one? I removed it from like here? Oh, maybe that was right. Yeah, now this one is exactly the one that we want adjusted. Okay. Now, it's a bit tricky with just 2 actuators to disassemble all this and throw some nitrogen on the end, I think. Maybe it's easy. I haven't tried, but it certainly looks a bit tricky. So maybe there's some way that that I could use one of these guys to remove the carbon's hydrogen atom, but I guess we'll cross that bridge if we end up needing more. So in the meantime, what do I need to do with this propene? This carbon is fine. This carbon is almost fine. This one needs more hydrogen and fewer bonds to this guy, right? So if I just like add a hydrogen here, what happens? Basically what I want, yeah? The trouble is that, like, the next obvious step is to remove this carbon. But I don't think that's going to work. Let me show you what will happen if I try. The obvious way to do that would be to, like, add another hydrogen to it so that it's unable to form any bonds. The problem is, yes, great, we did it. But now both of these carbons are satisfied, right? They won't want to form a bond with this nitrogen or with this carbon. They're already happy. I need to leave them unhappy for a while. Which, is a bit tricky, maybe? I mean, yeah, it's getting hard to see how to do this all with the limited number of actuators we have while still being reasonably efficient. But we do have, like, a long time to screw around, right? And we're not actually using this one for anything yet. Maybe 2 can step up here and fix this later, for example. I guess we probably want all these. Well, I can't move them farther south because they'll run in this guy's way. I can move them a bit this way. Right. What is 4 doing exactly? I don't know, nothing good. I think he was aiming at something complete. Oh yeah, right. Get out of here, 4. Yeah. You know, no. I was thinking, you know, this carbon is sort of in the right place for 2, the guy who's been doing all the pushing, to remove hydrogen from it at this point. But this is actually, like, too many cycles in. By this point, we should have already emitted the product. So that is a false connection. I was thinking maybe we could save 5, not need a 5 over here for that. And maybe there is some way to do it, but it's not just repurposing 2 in the obvious way anyway. Okay, so let's, I don't know. We'll have 4 start here and remove this so that these guys bond more happily. In fact, actually, maybe that is the solution to the question of, like, what to do with this excess carbon here. Is now this nitrogen, in order to remain happy, needs exactly 1 bond to the carbon, which means this carbon needs exactly 1 bond to this carbon. So even if we disconnect this guy, I don't think this carbon can form a double bond anymore. He's going to have to remain deficient until we allow him to become happy. And in fact, no. Well, here's one way we could maybe... I was thinking a way we could maybe save an actuator is, like, if 3 shunted a hydrogen into here instead of adding 1, as a way to get 4 hydrogens in the carbon, and then it adds 2 more. right? Something like this. Right. The problem is we now end up... Why do we have a double bond now? Ah. No, I don't get it. Ah, because this has allowed this carbon to retain the double bond with this one. So it's no longer excited to reach out to its new friend, the nitrogen. Okay. So let's not do that. That gets this bond going. And now at this point, if I really wanted to, I think I could shunt. Yeah, that disconnects these. And then add the bond back. Or the hydrogen back, I mean. Now it's in a position to bond with the new carbon that arrives here. The problem is I don't really have an actuator to spare to get rid of this that I can see. I mean, I can obviously move 4 down here and then move it back, but that's a... I guess it's not even really that slow, because 4 has been idling for a while, right? We just do this. And we can be back in position for the next one. Okay, I mean, that's pretty cool, right? Oh my god, did I really do this wrong? At the time all of this stuff is happening, this is when the benzene is ready, right? So first of all, I'm viewing it from the wrong rotation. Did that go the wrong way, or? Yeah, so I needed not 1 rotation, but 5. 2, 3, 4, 5. Yeah, now the benzene... No. Now the benzene is oriented like what's in this picture here. But I've put all this stuff together oriented wrong. It needs to be rotated a bit to attach to this. So I removed the hydrogen from the right carbon, but I put together this whole business in the wrong orientation. And there's great ways to reorient the whole board, but not pieces of it when you just messed up part of it. Ugh. So in what direction do I need to rotate this? We're set up like this. So this needs to go clockwise, like that. I think 3 is the one who has to come here. No. Oh, God. What did things look like before? Okay, so they looked like this, right? Yeah, so 3's job is to shunt from the middle carbon into the carbon that's closest to the propene. So he's faced something like this. And this is the carbon we're removing. So 4 needs to come over here. here. Okay. Now I've made, like, basically the right shaped thing here, right? And I've done it quickly enough that this stuff is all still being assembled. And so I believe I can just have 3 kind of push, like so. Was 1 push really enough? Did I do things right or wrong here? Something feels... I didn't expect this to be done. But looking over it, it does look correct. We're just not quite finished yet because 6 needs to sew this on. But I think the whole molecule can survive a rotation at this point, right? 3, just don't push it, please, and then someone output it? They're like so close to each other, it's frightening, but actually it's correct. Oh man, look at that go. And that's kind of interesting. The playback speed, like I just pressed spacebar, right? It's doing the playback here. And the playback speed is not regular. Which operations are the fast ones and which are slow? It seems like actually rotations are faster than translations. All the... Well, no. Oh, I think the cycles that are slow are the ones where molecules are added or destroyed via spawners or deletions. Yeah, okay. Those I think are the ones that are going slowly, right? Here... Well... This one seems kind of slow. I don't know. I don't understand it. Oh, right. This one's slow because that's when the nitrogen reappears, maybe? I don't know. Whatever. Pretty cool. Not quite 10th percentile on modules. You know, definitely about the mode. I'm not sure if how I'm doing in terms of median or mean here. And not too embarrassing on cycles. Pretty normal, in fact. But I'm very happy with this one, actually. It looks quite nice. I think you kind of have to do it this way. Like, doing something that involves 3 separate methanol molecule spawners would be a big nuisance compared to just rotating stuff around. So this is a good, like, train you to think about rotations, probably, kind of episode. They all resemble each other, don't they? The difference between helping and hurting is just a few atoms. Oh, I thought he was talking about people. One might get you high as fuck, and the other will kill you. Yeah, because I thought he was going to be like, oh, all these people are all the same. Blowing them up, no one will even know the difference, right? But sure. I guess molecules are indeed similar. I don't actually know what ketamine does. We'll look that up real quick. Dissociative. Okay. Those are no fun at all, is my... You know, as someone who basically has never done any interesting drugs, my understanding from people is that dissociatives are like a bit of a not that fun trip. But maybe, I don't know. What do I know? Anyway, that's all for today. Thanks for watching, and I'll see you next time.